Hello, everybody. We'll get started in about 20 seconds. Hello, and welcome to the Postgres live session, Building Always On Postgres, High Availability Across Clouds and Kubernetes. My name is Kathleen Tassa, and I'm on the marketing team here at pgEdge. We have a great session for you today with two fantastic presenters, Matt Moles, Senior Director of Engineering, and Paul Rothrock, Systems Engineer. Before I hand it over to Matt, I just wanted to go over a couple of housekeeping items with you. We will take any questions at the end of the presentation. If you have a question during any part, please put your question in the Q&A box located at the bottom of your screen. If we don't get to your question, if we've run out of time, someone will reach out to you directly one-on-one to get you the answer you were looking for. Also, this webinar will be recorded and will be sent to you out via email within 1 to 2 business days. And with that, I will hand it over to Matt.
Awesome. Thank you, Kathleen. Very excited to talk about this topic today. I just wanted to give a little bit of an introduction here on the opening slide about what to expect. I think there's two primary goals in the session today. We want to share some patterns on how to architect distributed applications to sort of maintain access to them during cloud provider or regional outages. So we're going to talk about not just Postgres in this, but also your applications that you're running that leverage Postgres. The second thing we want to do is teach you a little bit how you can deploy distributed Postgres today in Kubernetes with pgEdge and CloudNativePG, which is a Kubernetes operator for Postgres. And as part of that, Paul's going to demo sort of our distributed deployment across multiple clusters. So it's going to be kind of a nice demo that links in with some of the topics we'll go over. Definitely echoing what Kathleen said, if you have any questions, throw them out in the Q&A box and we'll loop back to them at the end. So let's get started. So what's the existing reality of this concept of always-on architecture? As many of you have experienced lately, existing infrastructure patterns that we're using, they're not exactly built for global resilience. I think a lot of us are using HA setups in our applications and our databases. They protect against hosts and availability zone failure, but they're not necessarily protecting us against when entire regions or providers are down and have service disruptions. And specifically cloud, control plane incidents in the major clouds or some of the smaller providers, they can remove entire regions from service, and we've seen that recently, obviously in the last month or so with the AWS outage and the Cloudflare outage earlier this week. Not to call those two out specifically, this obviously occurs across providers frequently. Another thing we've noticed is that user expectations have shifted. I think always on doesn't just mean, in one region. It means it needs to be available globally. Customers expect that they have access to your applications from wherever they are, and hitting, aspects of your architecture in different ways when there's outages in certain regions can be a tough experience. So that expectation has been raised a little bit, I think, in the last 5 years. Finally, databases remain the most difficult part of high availability application architecture. Obviously, it's been most common in relational databases to have single primary setups, and there are lots of strategies to move away from those. We'll talk about how we do that at pgEdge. But this has been the part that's been most difficult to make, cross-region in many cases. So we'll talk about that in the rest of the presentation here. In some ways, the way that I've experienced this is I feel like it's sort of like we're all playing cloud outage bingo, which is like a game I don't necessarily want to win. But when there's outages that have, specifically to do with certain services or certain providers, you're sort of hoping that, it's not part of your architecture necessarily. But some things are so large that they're bound to hit for you. So not to call any of these out specifically, like I said, I think everyone has an incident or two. It's about how you respond to it. So what does that traditional high availability architecture look like? It's largely meant leveraging availability zones. So applications leverage these multi-AZ setups through services and infrastructure that deploy across AZs. So you can see in the diagram on the right, you might have application services in your app that are deployed across availability zones. Those are in the same region, same cloud region, but they're deployed across floodplains and separated so that there's less of a likelihood that all of it's going to go down at once. And that's been applied to app services, object storage, message queues, relational databases like Postgres. What then you'll typically do is, balance your API requests across those availability zones. But we still have this issue where the database has a single primary instance. We're using replica standbys for situations where we can't get to that primary instance, but we're still stuck in one AZ for that database. Obviously, larger organizations are going to have different architectures here. This is mostly speaking to smaller organizations who are launching new applications, and then as they grow, they might take on more complexity. So what issues are inherent in this architecture? Those region-wide failures, like the ones that have happened in the past month, they still often result in downtime. So even though the AZ where your primary database is up, may be available, there's issues with the cloud control plane. It's unable to do a failover. You're unable to access things due to DNS. It ends up bringing you down anyway. It's almost as if you're paying for more infrastructure, but not getting the benefit of the high availability. As I mentioned, there's still only one primary database. One writer exists, and while that role can change and move across AZs with failovers, applications can have trouble with that concept when it changes. Um, when we're using replicas, we're also consuming resources that cost money, but they're often not leveraged directly. Applications sometimes can't necessarily use read replicas for reads if they're not architected for doing so, if they can't handle eventual consistency. So what's been the pattern is that applications have started to rely on these cloud-specific HA-enabled service implementations. So these are higher level services that make it easier to deploy quickly, but you end up getting locked into provider-specific implementations. So you see some services that say we're Postgres compatible and it's globally available, and we can guarantee you that it's accessed in multiple regions. But when you use such services, you're kind of cut out from some of the underlying features that you might want to leverage in a database like Postgres. And you're taking that trade-off to try to globalize them with those services, but it's sort of creating lock-in in your architecture. You're locked into that cloud provider. So how do you reduce your risk from that? That's sort of the challenge with this architecture. Obviously, Kubernetes has come along as an attempt or a reaction to this problem, and it's meant to create a consistent control plane that you can run everywhere and have it behave consistently. So standardizing layers on top for networking, security, and compute, and making it easier to run redundant services without using those cloud-specific HA services. So basically, I can run my applications anywhere as long as they use this abstraction in Kubernetes. At least that's the promise that Kubernetes is trying to achieve. And what that means is we can essentially abstract that, run it in multiple clouds, multiple places, maybe on-prem, and that can reduce our risk if we use this as a platform. With that said, Kubernetes itself has its own multi-cluster problem that you have to solve in order to be able to leverage it, across regions even. So for those who are familiar with Kubernetes, Kubernetes is most often deployed one cluster in a single region. It'll have, compute nodes that are deployed into multiple availability zones, but inherently it's not going to manage resources that sit outside that region. Now you can deploy it, folks have tried to deploy it across regions, but typically you deploy multiple Kubernetes clusters and then you connect them together. And so this has become sort of a subset area of how folks have used Kubernetes. And it's resulted in even a special interest group being defined called the multi-cluster or SIG multi-cluster. And their focus is basically how can we make it easier for you to deploy across clusters so that you can easily take your applications that might have been in one region and distribute them into multiple locations, getting that availability aspect. So not something that Kubernetes is going to solve for you right off the bat, but you do have the abstraction layer you can use. You just need to figure out some additional solutions for certain aspects. One of those aspects is networking. Obviously, if we're going to connect a cluster running in AWS with a cluster running in Azure in a different region, we have to figure out how we have a common secure network between those and how we can make sure that applications we deploy and their pods can access each other across the different regions. There's been a host of projects in the Kubernetes space around this. Some of these are, network layer 7 tools like Submariner and Cilium that I'm sorry, no, not network layer 7. I got ahead of myself. Network layer 3 and 4 tools like Submariner and Cilium that, are solving how we actually can make those pod-to-pod connections. But there's also been an evolution towards service meshes such as Istio and Linkerd that make it easier for applications to easily expose a service to another cluster once that underlying network layer is there. So there's lots of cool projects. Some of these are CNCF backed, which is the sort of umbrella organization that's around Kubernetes and Linux Foundation. So you can follow these projects specifically, but different companies, some of you may be using these tools in your organization, are going to have different ways they've employed these to solve this multi-cluster problem. Moving ahead, what about Postgres? I've talked a lot about non-Postgres and non-pgEdge stuff up until this point, which I think makes our marketing folks a little nervous sometimes. But it's the elephant in the room. How does this apply to Postgres? How can I use Postgres across multiple clusters, and how should I deploy it? We highly recommend using CloudNativePG, which is a best-in-class Postgres operator for Kubernetes. That's a CNCF-backed project now. CloudNativePG has a very, very high level of maturity in terms of what it's capable of doing in Postgres for you to manage your databases. It's an open source project. You can go out there and use it. We feel pretty good about it as a foundation for how our customers are going to deploy in Kubernetes. There's obviously lots of other operators, but we think this one is kind of coming out as the leader in the space. And so that's why we're mostly using it with our customers exclusively. One of the most important things about Cloud Native PG to understand if you're more from the Kubernetes space is that it exposes Kubernetes services for your rewrite and read endpoints to your database. That's the most important thing that it does for us, that it's going to enable us to access things across different clusters. Now, the first question we had is, well, does Cloud Native PG have a solution for this? Can you just use it directly to deploy across clusters? And the answer is yes, you can. You can see on the right, there's this concept of replica clusters in Cloud Native PG, and that's where you'll operate one Postgres cluster in a single Kubernetes cluster, and in another one, you'll operate a replica cluster. It'll use WAL replayed onto another primary there, but it's not necessarily an active-active setup. It's something where you would invoke that failover to the second cluster when you've determined that that's needed. So it's more of a disaster recovery scenario that it promotes, but it still could be useful in some architectures, so I like to call it out. So how can we use Cloud Native PG to think about distributed Postgres? So at pgEdge, we have a product called Distributed Postgres. It's built on standard Postgres, and it's supposed to enable geographic distribution of writes and basically make it easier for you to deploy high availability setups across regions. It's built on multi-master replication provided by the Spock extension, and which provides a lot of conflict resolution and avoidance features. We support a lot of Postgres extensions that you can use, and we're deploying, we're able to deploy some of those extensions to support edge AI and distributed AI use cases. So what our goal has been is how can we make it easier to deploy pgEdge on top of Cloud Native PG so that we're kind of a part of that open ecosystem of how you would deploy Postgres on Kubernetes. And so what we've done is actually build a Helm chart called pgEdge Helm. And pgEdge Helm makes it easier for you to orchestrate multiple Helm deployments across your multiple Kubernetes clusters. So in the end result of doing these deployments, each pgEdge distributed Postgres node in Spock's topology ends up as a Cloud Native PG cluster. So you can see in the diagram on the right, you have the CNPG operator running in each Kubernetes cluster. It's orchestrating each Spock node, which has obviously a primary Postgres instance. Those primary Postgres instances are connected together through logical replication to enable us to have data synchronized across multiple clusters. The chart itself has a Kubernetes job that handles wiring up those connections for you so you can make changes to your topology afterwards. And our goal is to make it easier for you to leverage Cloud Native PG's feature set. So there's this like level 5 operator maturity that's developed in Cloud Native PG. And we want to make it easier to utilize those features. So things like backup and restore, observability, you're able to leverage what comes in the base operator, but you're able to deploy the distributed deployment if that's in your use case. So how do you tie this all together into some sort of new shaped architecture that could help you be more resilient if you do have cloud provider failures? So obviously it's going to look a little different for everybody, which I think is a common theme that we'll talk about here. But this is just one view of it that's maybe a high level view. I think could speak to the different folks who joined today. The idea here is that applications should be deployed across clouds or even across on-premise locations in separate Kubernetes clusters, right? So we're able to use Kubernetes as that abstraction that makes it possible to have different deployment locations that we can go to that might have different, ways of operating, but Kubernetes is that abstraction on top of it. We interconnect those clusters using service meshes or other cross-cluster networking tools like the ones I showed before, and that enables communication between the clusters for them to almost behave as one in the case of cluster mesh. And that lets us deploy our applications on top of it. Um, we still want to think about availability zones here, and Kubernetes is built for that. So our applications in our database, we want to make sure we deploy instances across availability zones using placement constraints inside those clusters. It's not really demonstrated in this simple diagram on the right, but it's making sure if you've got an application like a web app serving an API that you make sure you're distributing that across multiple nodes and different AZs so that it's not susceptible to hardware failure and other failure scenarios. So how does the user get access to it? They would, basically, instead of hitting your load balancer that was in one location, they need to move up a layer. And there's global DNS tools that can help route to sort of the nearest healthy region that might exist and hit those load balancers that exist inside each cluster. This part's going to look a lot different for different organizations. But it's just a little bit different model. Basically, you're getting routed to the same application that's deployed in multiple places, is the way to think of it. And the most important piece here is that we're running multiple primary instances. We no longer have that problem where the writer is just in one location, right? We can write to the primary inside of the same cluster where the application is running. We can also fail over to the ones in the other cluster. And we'll talk a little bit more about patterns around this here after the demo. So I'm going to hand it over to Paul, who's going to kind of demo how you could deploy and use this in an application in multiple clusters.
Thanks, Matt. Could you stop sharing?
Yep, there we go. Just finding the UI.
All right. So I'm going to show you, it's great to talk about these at sort of a conceptual level. I'm going to show you what it looks like when this system is keeping your application running. So let's go over my environment, and we'll start with my Windows here. So in the upper left, I have an HA proxy status window. You can see it's got CNPG backends N1 and N2. These both point to separate Kubernetes clusters. You can see one is green and the other one is set up as a backup. In the top right here, I have the application built by one of our partners called Mattermost. If you're familiar with Slack, this is similar, but it's self-hosted, and it's used by organizations that need maximum uptime, governments, back-end communication for corporations. So this is the sort of application that you need to keep running no matter what. In the bottom left, I have a script that will post periodic messages to Mattermost, so you can see we can see it running because it's kind of hard to demo it not going down if it's not running. And then in this window, I'm connected to the system that's running our Kubernetes clusters. So the Kubernetes clusters are set up. There are two clusters. There's cluster A and cluster B. So let's take a look at the values for cluster A. And you can see that this one has one node named N1, and then it's flagged an external node as N2, and that's setting up that back-end communication, the logical replication between the two clusters. And then if we cat values B, we can see the settings for the B cluster, and we can see that N1 here is the external node. So these are wired up so that any modifications on either system will be replicated across the entirety of both systems. So this will ensure that everything's in sync and you can write anywhere. So let's take a look at what happens when one of the clusters goes down. So First, I'm going to turn hibernation on for cluster A. Otherwise, Kubernetes will do its thing and self-heal the cluster, and demo wouldn't work. And then we're going to go ahead and delete that pod. So if I do kubectl get pods, we get a couple read timeouts. And now the application is back up and running. So you can see this application, there was a little bit of a hiccup as HA proxy did the switch over. But as you can see, it switched over to N2 and everything's working just fine. And now just to show you that it is in fact running on this cluster and we're not, doing something tricky in the back end, we'll go ahead and turn hibernation on for cluster B. And then we'll force that pod to be deleted. And you see now they're both down, and we'll start to get 500 errors from our script and net timeouts. So it's actually running on that cluster. So let's go ahead and disable hibernation for cluster A. And as that comes back up, we will see Mattermost start getting messages again. And we'll do it for cluster B too. It's coming back up, and the application comes back up, and we'll turn on cluster B. So as you can see, this is set up in two different contexts inside of Kind, so we're running it locally, but the same sort of thing would be applicable for, if you set it up in two different availability zones, two different regions, or even two different cloud providers. So that's how it works to keep your applications running. So back to you, Matt.
Awesome. Thank you for walking through that. Let me pull my share back up. Okay, that looks like it's working. Yeah, just a little bit about behind the scenes. We were using Cilium cluster mesh in there. You saw those cluster set DNS names. I think this is going to be applicable to any way that you're exposing DNS. There's lots of different ways to accomplish that. One of the things I want to talk about is, different read-write access patterns that you need to account for if you want to employ, active-active in this way. The demo we just showed, we were using what's called maybe a single primary pattern, and which is, we are pointing all of the writes from both clusters to one primary. The reason we're doing that is, Mattermost is architected to kind of work with a single primary. So it's a good example of how you might take an existing application and still leverage active-active for that very quick failover. So most of the time we're pointing, at one cluster's primary, which is going to mean there's a little bit more latency if we're going across regions, right, for the other cluster. But we still have that capability to do a failover to a new primary using a tool like HA proxy, or there's a variety of tools we could use in that case. Different applications, depending on how you architect them, might use a few other read-write access patterns. One is the concept of a home primary, and that would be, inside each cluster, applications are talking to the primary inside that cluster. This works best when you have, tenants or apps that really aren't typically going into other regions, and you manage routing to your applications in that way, but you still maintain that capability to fail over to another region or a nearby region if you have like some sort of event that you need to account for. So still leveraging active-active, just different ways of actually accessing the primary is something you need to think about. The final one requires, that you think more about your application, which could be many, many services, which is fully active-active. It's sort of, I don't necessarily care which primary it's writing to because my application is architected for eventual consistency, essentially. So we know that we can make a write in one place and, we're going to be able to read it everywhere eventually, but we're built to handle that scenario. And so you get read after write consistency guaranteed locally, but you need to think about it a little bit globally. So when we have customers who come to us with their applications, we like to think about things in this model. Generally, you might move towards being more fully active in time, but you might have a lot of applications that you want to geographically distribute that you can't change. And so it's good to have flexibility in this case. Obviously, we mentioned DNS before, and I wanted to make sure we didn't gloss over this detail because we could do all the things we wanted to make our applications, our databases highly available, and DNS could still take us out, and probably for many folks on the call has taken us out. A lot of the cloud provider outages often involve DNS. There's a joke that it's always DNS. There are a lot of global solutions for how you can do load balance DNS routing to different places, but you got to make sure that you're not creating another single point of failure, right? That could take you out. So in the case, in the case of the Cloudflare event earlier in the week, it didn't take out their DNS, right? It was just the sort of network layer that they provide if you proxy requests. But these global DNS providers are great for doing those different routing solutions for application services, but we don't really recommend using those for your actual database, right? Routing to your database is best done with like Postgres native tooling, the integrations through HA proxy, sometimes PG bouncer is involved in combination with that, are going to help you meet those read-write access patterns. Or you might just be able to use CloudNativePG directly if you're doing some of those patterns. A friendly reminder that you can do, a secondary DNS provider can help you with your availability and making sure that if, you have your DNS all in one place, you're not putting yourself at risk of downtime, even if everything under the hood is all happy. Um, in closing, I just want to kind of leave everyone with a few notes for how to think about always on. I think of this path as a journey that you can consider how to take on at different stages in your organization's maturity. So it's all about identifying existing risks in your architecture and ask yourself what's worth addressing. Sometimes it is very valuable to use cloud provider services that give you HA because they have a lot more engineering power behind them, right? That you're kind of taking advantage of, especially if you're a small organization. But there may be specific parts of your architecture that you care about making sure are available that make you unique. So it's important to think about all of those risks. What's the risk of a region failure? What's the risk of an availability zone failure? And what happens if those occur? Once you have those risks, that can kind of guide you into what the next steps are. I always kind of recommend that you start with resilience of what you have and then expand to changing your application architecture. A lot of folks might not have strong single region HA with availability zones and proper backups and predictable failover in region. And those things can still cause you hiccups. So if you have, databases running single instances and, start there by adding redundancy where you need it. Then you can think about expanding to multiple regions and multiple providers once you kind of get past that. Um, we like using cloud agnostic tools. We talked a lot about Kubernetes in this presentation, and Postgres is also fits that bill, right? It's a tool that we can use a lot of different places. We can deploy it in Kubernetes. We can deploy it outside of Kubernetes. Using these types of tools are going to make it easier for you to move things around when you may be getting worse results from certain providers that you're using. And finally, we recommend everyone kind of evolve more towards active architectures. You saw Paul's demo. It's a much cleaner failover when it's just part of the way that the application works and not something that we're only doing when there's an emergency. Oftentimes when there is, some sort of emergency where, maybe an availability zone is down and I need to go perform an action, you can't do that if you're using some of the cloud provider provided services because those control planes might be down. So moving towards the model where it's just the way your application works, in terms of being more available and not a part of the DR story is generally something we recommend. Obviously we love using pgEdge distributed Postgres for that and leveraging Spock, but there's a lot of different tools for that out there. So with that said, thanks everyone for joining today. If you're interested in trying out pgEdge distributed Postgres, you can deploy it in Kubernetes, you can deploy it on-prem, you can deploy it in the cloud. You can check out our Get Started page that'll kind of guide you towards simple ways to run it and try out replication. Also, just want to call out, you can find both Paul and I on Discord. If you have questions, feel free to reach out there. We're generally pretty available, and we like to make ourselves available if you have questions about deploying these. We have a lot of open source tools with GitHub repositories. You can also file an issue on there if you're having trouble getting something set up. With that, I'll pass it over to Kathleen.
Great. Thank you, guys. We have a few questions. The first one is what can you use to manage multiple pgEdge Helm deployments across multiple Kubernetes clusters, like what was in the demo?
Yeah. I think there's a whole space in Kubernetes around deployment tools. I think most often I've heard folks using Argo CD, and that's the kind of thing where when you've got Helm deployments and you need to kind of stage them out, you can use a concept called sync waves in Argo CD, where you could be deploying to multiple clusters and then have like kind of a workflow around it. So that's kind of the next step. You can go through our Helm repo and see the individual steps you need to make, but most companies are going to have tools like Argo CD in place to do like GitOps flows where they commit the required Helm chart changes to your repository and then deploy out through Argo CD to their various clusters to get the deployment running and then also verify it before it goes out.
The next question is, how does the pgEdge Helm chart manage authentication for Postgres connections made across clusters?
Okay. Yeah. So the built-in way that it works is using certificate authentication by default. We do issue some passwords for certain users, but they're local to each cluster. But the users that we create for replication, so the pgEdge user in our default deployment is issuing client certs that are then verified by each cluster when the connection is created. This is a much better kind of like default behavior than having passwords that we need to keep in sync across clusters. And the default implementation uses like a self-sign setup, but most companies are going to be using Cert Manager already. And so they might have, a certificate authority and they could just follow the same pattern to plug in their cert authority to issue those certs.
Okay, perfect. The last question we have right now is, can you change the topology of your nodes after you first deploy the Helm chart?
Yes. Yeah. So you can exactly. So once you first deploy, in Paul's example, he had cluster A and B. If you add cluster C, you would just, orchestrate another Helm deploy that would run that init Spock job that runs in the Helm chart. And that would then, look across the existing nodes that exist and set up the required Spock configuration to make sure that everything stays in sync. When you add that third node, there's a concept called bootstrapping in the Helm chart. You can look it up in the docs that we have. We'll put a link in the chat. And you basically can just say, I want to bootstrap this node from another node. So load data from an existing database, one of the other nodes that's there. And that'll make sure that when replicated writes, come in after you change things, that they're based on the same sort of common data set that's aligned across the nodes. You can also use CloudNativePG's Barman backup restore to bootstrap the node, which can be useful if your database is like larger. So sometimes it makes sense. The chart will kind of protect you against that. If you're adding a new node, it'll require you that you bootstrap it to make sure that it's aligned.
Okay, we just got a bunch of questions on the Q&A also. If it's fully active and multi-primary and one instance is completely down, at which point does it sync with the latest data set? Is it when the pods are getting started?
Yeah, I mean, you could think of it like that. So when let's say I guess in Paul's example, when he took cluster A, turned CMPG into hibernate and, killed the pod, when that unhibernates, let's say a bunch of writes had occurred on the other cluster B in that primary, those writes would have built up wall on that cluster B side. And when cluster A comes back up, Spock is gonna restart those apply workers that are going to apply things across the clusters and then work on that backlog. So you're going to basically have what's called replication lag, right, for some time, where it's going to work through that backlog accordingly, and then things would catch up. So it is right when the pod starts up, basically, but it's kind of after Postgres initializes and then Spock initializes.
Okay. The next question is, your docs seem to not show how to load schemas into the database instance. I guess that's a comment.
Yeah, I think we could maybe if you want to reach out, we could help a little bit on Discord, whoever posted the question.
Yep.
But generally, the Helm chart is using Spock's auto DDL capability. And so what that means is in the app database, we've configured it to be the replicated database. And so you could PG restore, for example, into that database. So If you can't find something in our docs, we're leaning a lot on the CloudNativePG docs. And so most of the time you can use documentation there where it says, hey, loading your data in there, in which case you could run like a temporary vSQL client pod to do the restore, or if you have connection from your machine, you could do it as well. So there's a lot of different ways to approach that problem. So it's tough to document them all. But yeah, if you reach out on Discord, we can help.
And I have the name of the person, so we can follow up too. Okay, so the next question is, what is the restore strategy in multi-cloud?
Very, very good question. It gets a little bit more difficult, right? First, it's good to think about what the restore strategy is in Cloud Native PG, which is that in-place restores are not a thing in Cloud Native PG. And so what that typically means is that you're replacing the database. You're never sort of restoring it in place. A lot of existing DR plans for Postgres outside Kubernetes are we're going to restore it right where it is because it might be pretty large. The backup repository might be local, so we don't want to move it somewhere else, right? Might not have redundant hardware. But in Kubernetes, the concept is spin a different cluster up and restore it. So my answer would be it's going to look a lot different depending on your database and your use case, but you can use Spock to perform those restores. So let's say, maybe you lost a node. There was like a DR event in the cluster and the cluster is gone now. You could remove that node from your topology and then add a new node to the topology and bootstrap it. It's going to depend on the state of the other nodes at the same time too. What data didn't get replicated. And so there's a lot of different scenarios that organizations have to go through to make a DR plan for active-active. So I think it's another thing that we can help customers walk through, and that's kind of why we have a support offering around it. But yeah, it's important to read up on how it works in CMPG because it does dictate a little bit of that.
Okay, perfect. The attendee who asked that first question just had a follow-up saying like exec into the instance. So I'm thinking maybe we should follow up post webinar.
Yeah. So a lot of the documentation for pgEdge Helm is in our GitHub repository. So if you go to the pgEdge Helm GitHub repo, there's a folder called docs, and that has a lot of that information in there. I use it as a really good resource. So we'll send you that link after the webinar.
Yeah, it's
Yes, and
also
you
on
can also,
docs.pgedge.
yeah, you can get to it from our website also in the top right-hand corner.
I will put that, well, I don't know how to put that in the chat.
Perfect. I think that's it. That's all of our questions. I just want to thank everybody for attending today. And thank you to Paul and Matt for your great presentations. And we will follow up with some links in the replay of this session also in the next day or so. But thank you so much again for attending, and we hope you have a great afternoon.
Yep. Thanks, everybody.
So much. Bye.